Good morning to you all. Hope you are following me in this section of mechanization. Last time, Mr. Alumati, we did something in livestock science. We last had our lesson in Mechan, and we discussed the sources of farm power. We discussed different sources of farm power, and engine power was one of those sources. If you could remember some of them: engine power, solar power, electric power, then we have other power sources. So like us to put our attention on engine power. Now, like other power sources, we need a source of power to do farm jobs. We need power to do different farm jobs. Now, engine power is so instrumental. Unlike other power sources, this source of power is instrumental. Why? It is versatile. Meaning that it can serve several purposes. Very many jobs can be done, or many activities can be done using this form of power. So basically, it is used. The power that is produced in terms by the engine is produced in terms of horsepower. So we say HP, not head prefect, but horsepower. So it is produced in terms of that. So we have said it is also versatile. We have noted, and we have said being versatile, yes, it is. It's produced in terms of HP or horsepower. Now, at the farm there are very many activities that can be done and need to be executed using a certain form of power. And engine power, being versatile, it can help in handling those activities. However, we say when we were introducing Mechan, we looked at the benefits of using mechanical or using machines, and using other forms of power. So we saw engine power or use of machines was very so much important because of its versatility, because of serving very many purposes or doing very many activities or very many farm jobs. Now, I'd like you to go, if you can get the book called Principles and Practices of Agriculture. Volume 2. So you go and you draw, or you make a drawing of 4 stroke engine structure. Make drawing of a four-stroke engine structure, and you'll be in position to identify different parts of the four-stroke engine that are very important. An engine has very many parts, as you will see, but there are some that are important in power production, that are important in propelling the engine to do several activities that we have mentioned. For example, you could have parts like valves, okay? So you could have spark plugs, okay? We also have the cylinder, which is the main part of the engine. The cylinder, we have the cylinder heads, we have the piston, okay? Hope you can see these parts. You label them piston. We have the crankshaft, the one called shafter. We have the camshaft. All those parts are parts of this four-stroke engine structure. All the parts of the engine that is four-stroke. Now, engines can be grouped into very many categories of farm engines. Okay, we have those, we categorize them or we group them according to the power that these engines produce. Okay, we have those which have less than 20 horsepower, because I say power of the engine is produced in terms of horsepower, and then there are those which are more than less than 30. There are those which are not more than 50, okay, horsepower. So always in terms of horsepower. Now we also group these engines according to the number of strokes moved by the piston. The piston, if that engine, for example, in the cylinder, the piston moves 4 times, okay, 4 revolutions, then we say that this is a 4-stroke type, okay. Whereas if it is moves twice, then we say it is a 2-stroke type, okay. Now, these parts you see here have their uses, or maybe I briefly talk about them. The valves allow air or the fuel air mixture inside the cylinder, okay, for combustion. The spark plugs produce electric sparks that can be used to burn fuel for combustion to take place. The cylinder is, I could say, the father or the mother of the engine, because it is where all that I'm talking about, the combustion, will take place in the cylinder. Okay, cylinder is very important, one of the most important parts of the engine, because that is where power is produced, and it determines the power produced by the engine. If an engine has very many cylinders, then we term it or we call it a multi-cylinder engine, and it will produce more power compared to the one which has one cylinder. The one would term as the single cylinder engine. So we call it a single cylinder engine because it has one what? It has one cylinder, so say single cylinder engine. So it produces less power compared to a multi-cylinder engine, the one that has very many cylinders. Because in the cylinder, that's where power is produced. Now, the piston moves up and down during power production. You know that it transmits power produced in the cylinder to the crankshaft and the flywheel and so on. So it transmits power. It has very many other functions, and those functions are named or are as a result of its features that it has. Okay, for example, efficient compression of the fuel air mixture, because when it moves upwards, it has moved a stroke, and I don't know whether we can be in position. If I try to draw something here, uh, I draw a certain sketch, maybe of the engine, and then I draw a certain on each engine. There is, especially the four-stroke petrol engines. I try to draw this, and I try to name the parts for you to see. Hope I've already talked about these ones. Let's try to draw the four-stroke engine structure to see some of these parts. Okay, I'm now talking about the piston here. Now, this is what we talked of the spark plug. We say the one that produces releases electric sparks that burn fuel air mixture for combustion to occur or for power to be produced, because power is only produced in the engine after fuel has been burnt or after combustion. That is the explosion of the explosion or burning of the fuel will enable power to be produced, because engines convert chemical into electrical energy. Now, these are valves. So this is a valve. If it is, we put this out, it means this inlet, and if we say we put this out, it means this outlet, valve, inlet. Okay. Now, on top of the cylinder, there are two things here. There are two parts. One is TDC, another one is BDC. So TDC is top dead center, and BDC is the bottom dead center. So these two parts, the top of the cylinder, this is the cylinder. Maybe let me label for you. And this one here, this one is the what? The cylinder, the whole of it. And the one inside is the piston. Okay? So when you say TDC, TDC is the top dead center, or the maximum this piston can move and reach when it is moving upwards. The maximum the piston can move and reach the maximum destination where it can stop. It can move and stop here. If it stops there, it has moved maybe from here and it moves up to there. It has moved one stroke. Okay? If a piston moves from down and reaches the top, it has moved one stroke. Hope you're seeing the one stroke somewhere, the four-stroke engine. So therefore, what is a stroke? A stroke, we have said the piston moves from bottom to top. So a stroke is what? A stroke is the piston movement from BDC to TDC. Okay? A stroke is the piston movement from BDC to TDC. That's what we are, if we say it like that. So that means if a piston moves from this to that, it has moved one stroke. And also, if it moves again from TDC to BD, because it does not remain there. Okay? So that's why I would like to even include here and the vice versa. So you should know that it can move from here to there, from bottom to top, or from top to bottom. Okay? Hope you're following. Now, these are the parts that you can be in position to see, but there are other parts like the crankshaft, around crankshaft, crankshaft, there are camshaft, and so on. The crankshaft transmits the power produced from the cylinder by the piston, because the piston transmits it to the crankshaft, and then the crankshaft transmits it to the flywheel. The flywheel, as you shall see. That's why you should draw the four-stroke engine structure and you look at those parts. Maybe in our next lesson, I can try to send you a diagram so that you compare with what you will have drawn, and those who will have not drawn, you can check from that diagram. That does not mean that you don't draw. First, try to draw. In the next lesson, I will provide you with what I have. Now, if those are the parts that you can see, spark plug, you have seen a valve, you have seen the cylinder is where power is produced inside the cylinder. Okay, so, and I've told you the number of cylinders that engine has, the more the power it produces. The more the cylinders, the more the power. Okay, a bus cannot produce the same power as a piki, a motorcycle, because piki has as one cylinder. We have those with two cylinders and pistons. Now, whereas a bus could have even up to 16 cylinder, multi-cylinder, many cylinders. Okay. Now, I want us to very quickly look at this. Look at our topic, our main topic, okay, which is power production. Power production in four-stroke engines. How is power produced in four-stroke engines? Because I've said the stroke is what? The stroke is the piston movement from TDC to BDC and vice versa. So when the piston moves from top to bottom, it has moved one stroke. When it moves from bottom to top, it has moved another stroke. When it moves from where it has been to another destination, so it either moves from top to bottom or from bottom to top. So, but when it moves in that a certain direction, it has made one stroke. Okay, so therefore, the four-stroke engines move how many strokes to produce power? 4 strokes. Now, move 4 strokes to produce power. To produce power. Move 4 to produce power. Now, and you have said the stroke is a piston, is the movement of a piston from TDC to BDC, or from BDC to TDC. Wherever it goes, it has moved a stroke. Wherever it goes, it moves another stroke. And I've told you that TDC and BDC, I've said TDC means the maximum destination the piston can move when it is inside the cylinder. I say if this is our cylinder, okay, this is our, okay, if the piston moves TDC, BDC, okay, if it moves, if this is the piston here, okay, if it moves right from here, moves and reaches here, it has moved one stroke. And also, if it moves from TDC to B, it has moved another stroke. So the maximum it can move, the maximum destination when it is moving upwards, does not go up to the spark. No, it goes up to the TDC here, the maximum where it can reach. Okay, so from bottom to top, one stroke. From top to bottom, another stroke. From bottom, like that. Hope I'm becoming clear. Now, how can we define TDC? It is the maximum distance the piston can move when it is moving toward this, moving upwards. So when it is moving downwards, the maximum it can reach is BDC. Now, I've said the stroke is the direction or is the piston movement from top to bottom or from bottom to top. That's why I included the other word, vice versa. Now, we are talking of stroke, 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 stroke. There, we are talking of stroke. You need to know these strokes because power production for stroke engine, the question can be describe. I don't know whether we can write it. Describe how a 4-stroke petrol engine produces power. And this can even be 20 max, it can be 16 max, it can be 15 max. So you have to take note of that. So describe how 4-stroke, how does it produce? How does it produce power? Okay. Now, very fast. 4-stroke. So there are 4 strokes. 4 strokes. And these strokes are named according to the events that take place in that stroke. So there are 4 events, and each event has 4 strokes, and each stroke has 4 events that occur when it is taking place. So these strokes include, I want you to know them. I said 4. One is called induction or intake stroke. That one you should know it if you want to describe power production. Because induction, because I say each stroke has 4 events. 4 events take place. So they 4 from here, they 4 from the second one, they 4 from the third one, they 4 from the fourth one. Those 4 events make 16 activities or events that occur. Now, induction stroke, the second one is compression stroke. Now, in your biology, when they say describe, you even need to draw. No, here we do not draw. Okay? In our culture, when they tell you to describe something, it means you write, you answer logically. You write the points in order. Okay? So, the first stroke, this is the second stroke. This is the third that I'm writing. This is also the fourth one. Power stroke is the fourth one. Power or ignition stroke. So this is the fourth one. The third one. Okay? After the second stroke, immediately the third one starts. Just after compression, an engine is very automatic. So you should credit the one who made these power engines. Now, the fourth one is exhaust stroke. Now, that is the fourth one. There are also 4 events that take place here, 4 events take here, 4. So if you count, the total number of events will be 16 events. 16 events. Those are 16 different points that you should know. Okay, so if these are the strokes, when you're asked about describe how power is produced in four-stroke engines, describe the mechanism of power production in four-stroke engines. These marks can be got from these events. You write an event, four events, four marks, four events, another four marks, four events, another four marks, four events, another four marks. You already have 16. Okay. Petrol engines, there is a way they produce their power, and they produce it the same way as diesel engines, but one event changes, as we are going to see. Now, if those are the strokes and you want to actually learn how to name these strokes, you just need a small formula that I'm going to give you. And this formula is I consume portion every day. Very simple formula how you can get these strokes. So if I say I'm going to call it induction or intake stroke. I consume. Consume has a C. Compression. Compression. It's a very simple formula. I consume. You consume. What's not me? You, whom I'm giving the formula. P. Portion. Power. I'm calling it power. So when you say I consume portion every day, I've already talked of induction, C. Compression, P. Power. Somebody was telling me that if you don't consume portion, you consume ice cream. So, and I said if it is still I can talk of ignition. I can also talk of I and I say ignition, maybe. So E every day, exhaust. You see how you have already arrived at the four strokes. I have already arrived at my four strokes. I consume portion of ice cream every day. I standing for induction. C standing for compression. E standing for power. I standing for ignition, because this is power. The third is stroke. The first stroke, the second is stroke, the third is power. Ignition. The fourth is exhaust. Why induction? Why intake? That is where there is intake of the fuel air mixture in the cylinder. Intake stroke. Why compression? Why compress? That is the stroke where fuel that has entered into the cylinder is squeezed or compressed. Okay? I'm giving an example. Take an example if at all you use a syringe. A syringe and a needle. So if at all you use it to extract water from maybe a cup, you try to pull its piston. You pull it to suck in, to pull the water to come. A space will be created and water will come and occupy that space. So if that is a cylinder, and then when I push and I close, if at all I close the entrance of that syringe and then I push the water that is inside the syringe, you know what will happen? It will be squeezed and compressed. And when it will be compressed, when it is compressed, if it is now in terms of engines, a lot of things or a lot of activities, a lot of events will take place. First of all, the temperature will increase, the pressure will increase, and the volume of this mix of these contents you have pulled in will also reduce now because of the pressure that has been exerted. Now, if these are the strokes and you have known them, because you're answering the question, describe how power production takes place in four-stroke engine. Now you can say, if I am you, I will say power production takes place in four-stroke engine after the engine has completed four strokes, after the piston has moved four strokes. Okay, and then I will mention them, which include induction, compression, power, exhaust. I will talk about them. And then from there I will say, during induction, now talk at one, I'll pick one and talk about it. During induction stroke, the following takes place, or the following occurs. Now I'll be describing how induction occurs. Now I'll bring the events of induction in. After talking about the events of induction, now I will get to the events of compression. After talking about the events of compression, very fast after compression, power takes place. Ignition will occur. I'll talk about the events, the four, I'll put them down. Now, after talking about power stroke, I will now bring in the events that occur in the exhaust stroke, and I will be done with that question. Now, I guess you have known this silly formula that you can use to understand or to get to know the events. I consume, twice every day. I induction, consume compression, P power every day, E exhaust. Now I have said induction, that is where there is intake. These names of strokes were given according to what events occur there. In induction, the main reason for induction is the intake. That is where fuel air mixture is introduced in four-stroke petrol engines. In diesel engines, however, it is not fuel that is introduced in the cylinder. It is air that is introduced in the cylinder. Now, compression, that is where the fuel air mixture that has entered the cylinder here is compressed. Why? The piston moves upwards. It will compress, it will occupy this volume. Okay, when the piston moves upwards, is trying to go up to the TDC, it will squeeze what is here. Okay, that is compression. Compress fuel air mixture. In diesel engine, only air enters during induction. And now in compression, this air will be now compressed also. And then in power, why the power stroke? That is where actually power is produced. That is a stroke where power is produced. Okay? Stroke where power is produced. If you follow ignition, that is where ignition takes place. That's where combustion takes place for power to be produced. That's why we are having power as the third stroke. Exhaust, that is where, now after burning of the fuel, that is where exhaust fumes or burnt gases, the remains of after burning the fuel, that is where exhaust fumes are released outside or out through the outlet valve. Because I said there are two valves, the inlet and the outlet valves. So that's where they get their names. Now that you know the valves, I don't know whether you have got the strokes. So these are the events. I want to see how can we arrive at those events. How can we arrive at the four events in each stroke? There is a simple way how we can arrive at those strokes, and that simple way I'm going to give it to you. Now, we are saying during induction, what occurs during induction? What takes place? The following occurs. The following takes place. What takes place now? I want us to just know it. Now, this is assuming this is our um, our cylinder, our engine, and this is, I've told you, spark plug. Okay, and this is the valve. So there is inflow of the fuel air mixture. Okay, so this is the piston. Okay, this is the BDC where the piston can reach. This is the TDC, and this is the crankshaft, crankcase, not shaft. And this is the crankshaft. Now, what events occur? The events that occur are in this stroke, the piston moves downwards. The piston moves downwards. That's why I have drawn my diagram and I have not put the piston this side up. So inside the piston is inside. Now when it moves downwards, it creates some space there. So that space will allow entry of fuel air mixture. Entry of fuel air mixture. Fuel air mixture will enter into the cylinder. Okay? And the inlet valve is open or opens, while outlet valve closes. And lastly, therefore, we have said 1, 2, 3, we have said there are 4 events. The fourth one is that this stroke ends. This induction stroke ends when piston has reached BDC. Remember, I told you when the piston moves downwards, the maximum it can reach is the BDC. When it is moving upwards, the maximum it can reach is the TDC. So, when we say the piston moves downward, it means this stroke will end when the piston has reached where? BDC. In a stroke where we say piston moves upwards, it means that stroke will end when the piston has reached where? TDC. Now, in order to get these 4 points, for each stroke here, there is a very simple formula. Don't you think we can know this formula? Okay? Very simple way to arrive at those events. Because you're going to write like this, you come to compression. During compression, the following occur. You write the 4 events that occurred there. You also come to power. You also go to exhaust. Now, if you want to know how really these events I have got them, you will need to know 4 things, 4 parameters. That I'm using. 1, in order to know where I've got point 1, where I've got this point of valves. Nature of valves. Nature of valves. How are the valves? How are the valves during induction? How are the valves during compression? How are the valves during power. How are the valves during exhaust? Nature of valves. 2. Another parameter, direction of piston movement. 3. So how will the piston move during induction? How will it move during compression? Because the piston moves like this. How does it move? Down, up, down, up. That's how the piston moves. In the first stroke, it moves downwards, induction. In the second stroke, it moves upwards. In the third stroke, which is power, it moves downwards. In the fourth stroke, it moves upwards. That's how the piston moves. Okay? So this is the first two parameters, 3. This is 1, 2, 3. The third parameter, you need to know the cause. What is the cause, or what is the reason for the stroke? What is the reason for the stroke? Each stroke has why it is there. Now, for example, you saw me writing entry of fuel air mixture. That is the reason for induction stroke. What is the reason for compression stroke? Compressing of the fuel air mixture. What is the reason for the third stroke? Power. Because that's why power is produced. The spark is released from a spark plug that burns the fuel air mixture for power to be produced. What is the reason for exhaust stroke? Exhaust fumes, burnt gases are released from the outlet valve. That is the exhaust stroke. So that each and every stroke has a reason why it exists. The fourth parameter is the final destination of the piston. Final destination of the piston. Now, this one is very simple. How simple? If you know the direction of the piston, you will be in position to know. If at all you know the direction of the piston, you will know the destination. How? For example, we say, how is the direction of piston movement in these strokes? The first one, say down, up, down, up. So down, up, down, up. So when it is moving downward, what will be the final destination? BDC. Compression, when it is moving upward, what will be the final destination? TDC. So BDC, TDC, BDC, that will be the final destination. So if you follow this, you'll be in position to get these strokes. Now, for example, let me rub these events and we develop them. Let me rub these events and we develop them. This piston is moving downwards. Okay? Now, I want to start now. So that I use these parameters to get these points, these 4 points. How am I using it? 1, nature of valves. During induction, what happens? How will the valves be? During induction, inlet valve opens, outlet valve closes. That is the first event. And I've got it exactly from here. Nature of the valve. How are the valves? Are they open or they are closed? Because during induction, inlet is open, outlet is closed. It is exactly the opposite of the last stroke. If inlet is open and outlet is closed, the opposite, what is the opposite? English. Now, I'm not using Nyankole. Now I'm using English. If this is inlet open, outlet closes. Now, in exhaust valve, how will it be? Inlet closes, outlet opens. That is the nature of valve in this and that. And these two, compression and power, how are the valves? During compression stroke, both valves closed. During power stroke, both valves closed. Now I'm done with nature of valves. In all, if at all you had your book there, you will see, you will get all the events. Now with this board is not enough. I'm only having the events of induction. I'm only having those of induction. But I could also be having compression somewhere. I have power also somewhere. So I would be just filling in inlet, close, outlet. Then I will go to compression, I write about the valve. Both valves closed. But in your name, we do not mark that. You understand? Both valves, which valves are you talking about? So you say both inlet and outlet valves remaining closed. Okay? So that's the way we answer. Now we go, now that we have finished the nature of valves in all the four strokes. How is it? Induction, during induction, inlet opens, outlet closed. I said it is exactly the opposite of induction in terms of valve. It is what happens in exhaust. In exhaust, inlet valve closes, outlet valve opens. That's why when it opens, the exhaust fumes are expelled. Now, the second point. Remember I said in the compression, the valves and the power, both are closed. So you have already got the point about valves. Point 2, another event, is about direction of piston movement. Remember I said, how is this direction? How does the piston move in power production? I said, you just need to know. The formula is very simple. Down, up, down, up. So that is the formula. Piston moves down, in another stroke moves up, in another it moves down, in another it moves up. Direction of piston movement. And remember, I even told you that this direction determines point number 4, final destination. If it is moving downwards, where does it end? Remember, I told you when it is moving downwards, the maximum it can reach is the BDC. When it is moving upwards, the maximum it can reach is the TDC. Now, if at all you know the direction of piston movement, you already have the answers for direction of piston movement. Now, during induction, we say down, up, down, up. So during induction, how do we write? We say the piston moves downwards. Remember, we are talking about direction of piston movement. Now, we another point. We are still on induction. When you go to compression, this diagram will change. How will it change? You will show things to do with the compression. But this is the fuel air mixture at any time. Fuel air mixture. Okay? Now. Number 3, the cause or the reason for the stroke. What is the reason for? I said induction or intake. So that is where the fuel air mixture enters. Fuel air mixture enters the cylinder. Okay? Enters the cylinder. That is the reason for induction or intake. Taking in. Now, The fourth answer, the fourth event of induction, final destination of the piston. Now that the piston moves downwards, what will be its final destination? Where will it stop? It will stop at the B, D, C. So you say this induction stroke ends when the piston has reached. Where has it reached last? When it is moving downward, it will reach here. It will reach the B, D, C on the bottom dead center. And you will be done with those four events. But you see where I have been extracting them through the parameters. Now, that is in action. So, can we look at now the events that take place in compression stroke? Very fast. I don't know whether the time will allow, but at compression stroke, I'm going to change because the piston, according to the strokes, what will take place in compression? Inlet, I said you talk about them. You don't say both valves closed. We do not mark you because you have not talked about the valves. Okay? Both inlet valve and outlet valve close or main close or they close. That is the marking point, close. Now, what about the direction of piston movement? We say down, up, down, up. So, see, compression. So, during this stroke of compression, the piston moves upwards. That will be the point. Another event number 3. Cause, what is the reason for compression? Now, point 3. When it moves upwards, so fuel air mixture in the cylinder is compressed due to the upward movement of the piston, because the piston is moving upwards. So when it is moving upwards, that's why this diagram is changing now. You see how I'm going to change it? Now it is wrong. It is describing induction. So now I remove my piston. I move my piston. I come and draw this piston up. You see? I will draw this piston here. It has moved upwards. It is compressing this fuel air mixture. It has even decreased volume. You see the piston. The fuel air mixture now is here being compressed. Fuel air mixture compressed. Okay? So the diagram has changed. And then I will change here. The piston was moving downwards. So how am I changing? I'm going to change here. Look, this one I'm changing and I'm saying no. The piston moved upwards. Therefore, I will do it like this because piston moved upward. Now I have changed it. The direction of the crankshaft. Now it is up. Okay? So last 3. 1, 2, 3. 1, 2, 3. So the fourth parameter is final destination of the piston. Now if the piston moves upwards, where does the stroke end? So it says stroke ends when piston reaches TDC, top dead center. So those are the events that take place in this stroke. Those are the events that occur in that stroke. Very quickly, can we move on to the third? The third one is power. And you see how power is produced. Which events occur? Events that are occurring in power. Power or ignition stroke. Power stroke. What happens in power stroke? Nature of valves. How are the valves in power stroke? We say in power and compression, the strokes remain what? Closed. So how are the events? Inlet and outlet valves remain closed. That is the first event. Where am I getting? Nature of valves. I said during induction, inlet open, outlet closed. During exhaust, outlet is the one that opens, inlet closes. During power and compression, they remain closed. So number 2, direction of piston movement. Remember I said down, up, down, up. So where is the piston moving? The piston moves where? The piston moves downwards. 3. Where is the third thing? Now, cause or reason. That is where power is produced. So, if that is where power is produced, now we're going to talk about how power is produced there. It's because it is the reason for this stroke. A spark is released from the spark plug here, from a spark plug, and burns fuel air mixture. That is the reason there. Now, there is a difference in power production when it comes to diesel engines. The difference is here. Diesel engines do not have spark plugs. For them here, on top of their cylinder, there is an injector nozzle connected from an injector pump. At this moment, where compression, I told you air is the one which enters in the cylinder of diesel engines. Where air has been compressed, just after compression stroke like these petrol engines, for the diesel engines, what happens is when, like you see, when fuel air mixture has been compressed, its volume decreases. Temperature, because it has been compressed, its temperature increases, the pressure increases, and what happens is very simple. Because of what has happened, because of the reduction in volume, increase in temperature, at that moment, an electric spark will be released from a spark plug. In petrol engines, but in diesel engines, at this moment, there is no spark plug. What happens? Air has been compressed, its volume decreases, and the volume of air decreases. The temperature of air at that moment increases. What happens then? An injector nozzle, okay, releases diesel fuel. Okay. It flows through the injectors into the cylinder and burns. It finds hot compressed air. Burns hot compressed air. Power is produced. So that is the difference that is there. Now, what will be the last final destination of the piston? If the piston moves where? Piston moves down. Where does the stroke end? So it says stroke ends when piston has reached this, because remember it moved where? Downwards. That is number 3. What about the last stroke? I don't know whether we are following. Which events occur in the last stroke? And even the diagram changes in our stroke. Changes because we say this moves downwards. This moves downwards. So because of that, there is an explosion here. So because of that explosion, the piston will move where? Downwards. So you have to show that on the diagram. And this will have to change also, because it's moving downwards, it will have to face this side. Okay? So it is moving downwards like that. Now, If this is what happens, now what happens in the fourth, in the exhaust? What happens in the exhaust stroke? So in the exhaust stroke, like we have been identifying different events, we begin again with the nature of valves. How will the valves be? Okay, remember I told you that nature of valves, valves in induction, inlet open, outlet close. I told you it is the opposite of induction is the exhaust. So the inlet this time closes, inlet valve closes while outlet valve opens. That is the nature of valve. What about direction of piston movement? The piston, because we say down, up, down, up. So the piston moves upwards. I don't know whether we are following. So what about the cause? The cause is exhaust. What exhaust? So exhaust fumes. Exhaust fumes as a result of burning of fuel will be expelled, are expelled, are expelled. Oh, something is disturbed. Exhaust fumes are expelled from the cylinder through outlet valve. So they leave. These will leave. So you will see, you draw and show them leaving, and then these valves. This thing will not be there. So you will show that they will be leaving exhaust valves. Will be leaving the cylinder. And now this valve will be closed. Inlet will close, outlet will open. So the diagram will still change. Okay, and now here you will show that the piston is moving where? Upwards. So what about the final destination of the piston, the fourth event? The stroke ends when piston has reached BTDC. And you are done with the 16 points, or the 16 events take place. Now, very fast, there's something that happens, and you need to know it. So if you have been following, you will understand it. So we have finished answering the question describing how power can be produced in four-stroke engines. Now, very fast, I want us to look at something that occurs in stroke number 3. We need to know it. Something that occurs in stroke number 3. Something is called firing order. Something is called firing order. Firing order is the order in which order of ignition, order in which burning of fuel occurs. Firing order is the order in which ignition occurs. Order of ignition. It's units also. So 1, 2, 3, 4. So cylinder 1, induction, compression, power, exhaust. Induction, compression, power, exhaust. So that is what occurs. Power or ignition is occurring where? Ignition is here. So if That is the order. At first, ignition occurred in the second. In the first one, that is where is intake of the contents of the fuel to be burned. Next time when firing order is going to happen, if it was 1, 2, 3, 4, next time it will happen in the fourth one, and number 4 will come this side, number 3 will go where number 4 is. So it will occur where number 4 is, and now firing order will be 1. Tell me now, if 4 comes here, how will be the order? 2 will go to where 3 is, and 3 will go where 4 is. Therefore, the firing order will be 1, 4, 2, 3. So firing order, there are very many uh, examples of firing order. Now that has occurred there, next time when it is occurring, don't ask me one that is where we bring in the contents. Okay, so where will it occur next time? Next time it will be, so if it occurs like that, this 4 will go where 2 is, this 2 will go where 3 is, and therefore this 3 will come, it will be 1, 3, okay, 4 will come where 2 is, 4, and 2 will come here, 3, 2. That will be another firing order. The other firing order will be now, this 2 will come here, this 3 will come there, and 4 will remain. And now we are going to be 1, 2, 3, 4. So those are different examples of firing order in a 4-stroke engine. If it is a 6-stroke engine, this will be different. There will be 5 there, and there will be 6 there, and it will be confusing. But now this one is not confusing, because you have known what happens where. At first, ignition occurs here. Now the second will be in this cylinder. In another light, it will be in this cylinder. Another time, it will be in the other cylinder. Another time, like that. Okay, so that is the order in which ignition will be taking place. How is power produced in diesel engines? I've told you. Okay, I have told you. Now, 4-stroke engines, there is a way they are beneficial compared to 2-stroke engines. So there are some advantages, because 4-stroke engines are more efficient in fuel utilization compared to 2-stroke engines. 2-stroke engines use a lot of fuel for a small piece of work, while 4-stroke engines use less fuel for a bigger piece of work. So 4-stroke engines have bigger crankcases. You have seen the crankcase that I've been drawing, okay, and heavy and absorb vibrations of the engines. A lot of vibrations take place there as power is being produced. You will not hear any vibration as compared to those small engines. Have you heard the sound made by a lawnmower, a machine that cuts grass? When it is cutting grass in the compound, usually here at school, you will hear a lot of sound from it, a lot of vibration, because it is small, it has a small crankcase, and therefore the 4-stroke type have bigger crankcases, which will absorb. The sound will be there, but you will not hear the sound and what is taking place there. Okay, so more frequently cooled, mostly by water. Most 4-stroke engines are cooled by water, okay, as compared to 2-stroke engines that most of them are air cooled. They are cooled by air. When they heat up, it is air to cool them, okay, not water. And Four-stroke engines, even when I started, I said they perform a wide variety of jobs. Okay, very many jobs. Okay, the engine can be used to pump water. Still, the engine can be used to move or to propel a grinding mill. Okay, where you grind maize to make flour. You can use uh, an engine. Okay, can be used for plowing. Okay, when they are attached onto maybe um, um, a tractor, not a tractor, plow, not to a plow. Okay, they can plow. An engine attached to a plow, it can be used for plowing. So they do several harvesting, planting, and so on. Engine can do several activities, okay, compared to a two-stroke engine. Four-stroke engine, they do several jobs, or a wide variety of jobs. Now, what are the disadvantages of four-stroke engines? Of course, their initial maintenance cost is high. Maintaining an engine that is four-type, fuel, buying fuel, repairing it in case it gets any problem, the cost might be high. Now, um, they could require the four-stroke type require more skills to operate them compared to the two-stroke engine. And four-stroke engines cannot be used on a uh, hilly terrain, a hilly area, while two-stroke engines can be used. For example, you have a motorized chainsaw, a machine that cuts trees, okay, machine that fells trees. If you have had a machine that cuts wood, okay, here at school we have it. Hope you have seen it in school, the motorized chainsaw for cutting firewood. There at the kitchen, you have been seeing it. Uh, the kitchen staff cutting firewood. Now, that machine you can even use it along a hill where you cannot use a four-stroke engine. Okay, it only operates on a flat area, not on a hilly area. So therefore, four-stroke engines also have some demerits. Okay, whereas two-stroke engines have their advantages, which are disadvantages to four-stroke engines, whereas four-stroke engines have their advantages that are disadvantages to two-stroke engines. Now, before we end, I want us to look at the differences between, let me emphasize this difference because it's a common question, differences between petrol and diesel engines and diesel engines. Now, if at all we have petrol engines this side, another name for petrol engines is spark ignition engines. They have a spark plug, spark ignition engines. Oh, this pen is not right. And this is diesel engines. Another name for diesel engines is compression ignition engines. Compression ignition engines. Spark ignition engine, compression ignition engine. Why spark? They have a spark plug. Compression, these ones do not have a spark plug. All diesel engines have no spark plug. That's why I told you the way power is produced in these engines is different. Okay? That's why I told you that An injector pump injects diesel fuel and gets mixed with hot compressed air, and burning takes place, or combustion takes place. Now, when you are given these differences, what you write here, for example, if we say spark plug, then you say these ones have spark plug. These ones do not have spark plugs. Okay? Now, you do not have a spark plug, do not have. You have to bring this word here. Have, do not have. But when you say do not have and stop here, you don't have a mark. And these differences are not, and the whole of this is 1 point. So if I'm to mark, I put a tick in between. So when you say do not have and stop there, you have failed. Do not have what? Can operate with a battery may not be necessary. Have an injector pump, have a carburetor, have an injector pump. Okay, so there are very many other points. These ones produce more smoke, produce less. These ones have more starting problems because having the battery. The others do not have, they have less starting problems. These ones, there is compression of fuel air mixture. Here there is compression of only air. Why fuel air mixture? Because they have a carburetor, because the carburetor has 2 roles that it plays, because it mixes fuel and air to make the fuel air mixture, and also at the same time it also we say it vaporizes, it mixes fuel and air, and then it atomizes fuel into fine sprays. Okay, so it reduces, it supplies a reduced amount of fuel in terms of droplets. Okay, that is why when the engine is lacking or it has a faulty carburetor, then it will have to use a lot of fuel. Carburetor, injector. So I'll end by giving you another question. I will end by giving you another question which says, describe the operation mechanism of a 4-stroke diesel engine. This question is the same as the first question we looked at. How a 4-stroke diesel looked at a 4-stroke petrol engine produces power, Okay, so this is how max 16. No, I believe it's 20 max. So next time, and then you're supposed also to give other differences between spark ignition and compression ignition. So next time we are going to look at um, engine systems. Next time we are going to look at engine systems, or the systems of a four-stroke engine. So make sure you try out this question. Remember, we say that among the events that take place in a four-stroke engine, among the events take place or occur in four strokes. Each stroke has four events. Each stroke has four events, and you saw the parameters are used to produce those points. The four parameters are used. Okay, so use those parameters to produce the 16 points, and after that you draw the four-stroke engine structure that will show all the basic parts of the four-stroke engine. So you should remember somewhere on the event of on the stroke of induction. I told you that is where in diesel engine, instead of fuel air mixture enters the cylinder, we in diesel engines, since they do not have a carburetor that mixes fuel and air, we say only air enters the cylinder. When it comes to the second stroke compression, where we say fuel air mixture is compressed, there we say only air is compressed. Okay? Whereas the other events remain the same. Okay? The events to do with valves, the events to do with direction of piston movement, and so on remain the same. Same as in petrol engines, what we have discussed here. Okay. Now, when it comes to power, you do not say that a spark plug releases a spark. No, you say that when after air has been compressed, okay, its temperature has increased and its volume reduces. Okay, it becomes very hot because its temperature increases. So what happens? An injector pump injects diesel fuel into hot compressed air, and then burning takes place because fuels are highly flammable. So when it injects that diesel fuel and gets mixed up with hot compressed air, burning automatically takes place. The other points remain the same, and well, the exhaust stroke for each, I think there is no change. It is the same as the one for petrol engines. So I wish you well. Keep practicing. Okay, I wish you well.